So we've all seen the hype, right? The promise that you can build an entire app from just a single sentence. But if you've actually tried these AI coding tools, the reality is, well, it's a lot messier. Today, we are going to cut right through all that noise. We're going to lay out a really clear framework for where software development is actually heading, moving way beyond simple AI assistants to fully autonomous teams. Let's dive right in. All right, so here's our game plan. Think of it like an hourglass. We're going to start broad with a serious reality check on the AI tools we have today. Then we'll narrow our focus to the single most important shift in thinking we need to make them work. After that, we expand back out to see the huge ripple effects this has on everything: testing, observability, and of course, what it means for the future of the developer role itself.
Okay, first things first, the reality check. You've seen the slick demos, but how do today's top AI coding tools really perform when you give them a real-world task? Let's take a look at the actual data.
Yeah, we've all seen those build me a to-do app videos where it just seems like magic happens. But what happens when you move past a little toy project and try something real, like building a standard API from a technical document? Well, a recent benchmark from Amultiple did just that. They gave a bunch of leading AI tools a standard API document and one simple prompt: build this. And wow, the results they're pretty telling. As you can see, not a single tool got it right on the first attempt. I mean, we're seeing everything from completely failing to create an API at all, to generating the wrong endpoints, to just not even supporting the right tech. This isn't just a small bug, it's a fundamental failure to do the job. So the bottom line is this: when you put these tools up against real-world complexity, that whole magic wand, single prompt approach just completely falls apart. And the issue isn't that the AI can't write code. It can. The problem is we're giving it absolutely terrible instructions. And that brings us to the absolute core idea of this whole explainer. If these vague conversational prompts just don't work for serious software, what's the alternative? Well, the answer is to move from what people are calling vibe coding to engineering with actual concrete blueprints. This slide just lays out the two paths perfectly. Over on the left, you've got vibe coding. It's that kind of chaotic back-and-forth conversation. It's great for messing around and quick prototypes, but it almost always leads to a huge, messy pile of technical debt. But on the right, you have spec-driven development. See how that clear, organized blueprint leads directly to a clean, production-ready system? It's really structure versus chaos. So what is spec-driven development, really? It just means you stop chatting with the AI like a buddy and start giving it a proper engineering blueprint. This formal spec becomes the one and only source of truth. And it really is the classic garbage in, garbage out scenario. A vague spec will get you a buggy mess, but a precise, detailed blueprint, that gets you production-ready code. And the workflow itself is just so logical. First, you, the human, specify exactly what you need in detail. Then, from that spec, the AI plans out its whole approach. Next, that plan gets broken down into smaller, concrete tasks. And only then, at the very end, does the AI actually implement and write the code. You're replacing all the guesswork with a predictable engineering process. Okay, but having a detailed blueprint, that's only half the battle. To actually execute on these complex plans, you're going to need more than one AI. The industry is realizing, and fast, that a single AI assistant just isn't going to cut it. The future is all about coordinated teams of specialized AI agents. And the model is actually pretty intuitive. Think of it like this. You have a lead orchestrator agent. That's basically the project manager. It takes that high-level blueprint, comes up with the strategy, and then delegates the real work, the coding, the testing, the debugging, to a team of specialized worker agents that can tackle all those tasks at the same time. The researchers at Anthropic put it perfectly. They said even generally intelligent agents face limits when operating as individuals. Groups of agents can accomplish far more. It's a simple truth we see with human teams all the time, and it applies just as much to AI. And get this, the data is absolutely mind-blowing. In their tests, Anthropic put a single, super powerful AI up against a team, and that team had one smart orchestrator and several less powerful worker agents. The result? The team outperformed the lone genius by over 90%. Just think about that for a second. You get better results using cheaper, less powerful models, all because of teamwork. This isn't just a small improvement, it's a total paradigm shift. Okay, so we've got our two core concepts down: detailed specs and autonomous agent teams. Now let's broaden our view back out and see how this new way of thinking completely changes other parts of the development process, starting with testing.
The evolution of testing is the perfect example of this whole shift. In the past, it was 100% human intelligence. QA engineers writing every single script by hand. Right now, we're in this assistant era, where AI helps us do that faster. But the future, where this is all going, is fully autonomous. And I mean, we are talking about AI agents that can actually watch real user behavior and generate entire test suites all on their own, making sure the tests cover what people actually do in your app.
Now, this creates a really important distinction you need to understand when you're looking at different tools out there. At the very bottom, you have the legacy platforms. With a little bit of AI bolted on, let's be honest, it's mostly marketing. In the middle, you have the AI-assisted tools. They're useful, for sure, but a human is still driving the whole process. The real revolution, though, is at the top, the truly AI-native platforms, where autonomous agents don't just help you with tasks, they actually own the final outcome.
But having teams of autonomous agents building and testing code at machine speed creates a huge new problem. You could end up with a massive black box. I mean, when dozens of AIs are all working at once, how do you possibly understand what's going on inside? Because if you can't see it, you definitely can't fix it when things go wrong. And this is exactly where the concept of software observability becomes absolutely critical. And this goes way beyond old-school monitoring that just tells you if a server is up or down. Observability is all about having the power to ask your system entirely new questions that you couldn't have predicted, to debug those unknown unknowns. It's the difference between knowing that something is broken and understanding why.
You get this power through three key pillars of data. You've got logs, which are like a detailed diary of every single event that happens. You have metrics, which give you the high-level numbers over time. And maybe most importantly in these complex systems, you have traces, which let you follow the complete journey of a single user request from start to finish, seeing every single service it touches along the way.
I love the analogy on this slide because it's just perfect. Traditional monitoring is like the warning light on your car's dashboard. It can tell you your oil is low, but that's it. It only answers questions you already knew to ask. Observability, on the other hand, is the mechanic's entire diagnostic toolkit. It lets you plug right into the engine and ask any question to find the root cause of a problem you've never even seen before. So, let's bring it all home. We've got spec-driven development, we've got autonomous AI teams, we've got AI native testing, and we have deep observability. This brings us to the biggest, most important question of all. Where does the human developer actually fit into this new world?
Well, the role isn't going away. It's just leveling up in a big way. As you can see here, the job is shifting away from all that heavy keyboard work, the manual coding, the boilerplate, the line-by-line debugging. The new focus, the most valuable work, becomes strategic. It's about designing system architecture, crafting that perfect specification to guide the AI, and, crucially, validating that the final output actually meets the business goal.
Ultimately, it all comes down to this. AI is getting incredibly good at mastering the how of writing code. So our new job, our uniquely human value, is to own the what and the why. The what is the perfect specification that guides all the work, and the why is that critical human judgment that makes sure we're building the right thing in the first place. So the real question is, are you ready to own the what and the why?